All right, let's get started here. This is calling it lesson set 14, but it's going to be a test for the class. Trying to overlearn this material so that it's working knowledge when you get to your next level of study. You don't actually have to think about this stuff too much and you can work with it. And so it's just like times tables. You got to overlearn your times tables so that they're, just 3 times 5, 15, you just say it. Same thing here. What I've decided to do is put most of the problems on the board so you can screenshot. So let's see, there's starting with problem 1 all the way up through 43. Don't have a lot of time to be doing these things, so I'm going to do them quickly. And I suggest you maybe try all the problems, and then I've got the answer key over here, which I'll show you in just a second, so you can refer to it to see how you did. And maybe I'm out of the way here. Maybe you can screenshot just about everything. Let me go back a little further. Maybe just that little bit can capture the whole screen. Renee helps me out here. Pretty much. Yeah, I think that actually helped. Let's see. 1, 2, 3. There we go. That's the border on that side. Okay, hopefully if you screenshot that, you can see the questions I'm asking. Equation of a line, a lot of mechanics, some functional work, a little Pythagoras. And what I'm going to do is I'll do them one at a time and I'll erase and talk about what I see. So maybe mental math on my part, but then doing it out or talking about what I see as I do it. I don't know. We'll see. But I'm hoping to get this done fairly quickly because I got another one to make, the second half of the video, which relies heavily on graphs. The last 60 to problem 60 to 70, I think are the guts of the test. And what I'm hoping people start to see is that I'm creating functions where we're multiplying by 0 and adding c, and also multiplying by 1 and adding c to help us quickly graph what we're tackling. And so keep an eye on that now, and I'll point it out as we go along. All right, so excuse the pace, but I don't know any other way to do this. So I've got to show you the answers. These are what I did a little while ago and wrote them down, and I hope they're right. We're going to check them as we go along, but that's the answer key for each problem, and we'll have at it. All right, the only problem I had to put pencil to paper to was problem 1. And there's too many terms to kind of keep track of here. But in order to tackle this one, I think it's best. Okay, now I'm going to start moving Renee around. Renee the cart. I think it's best to put them in columns. So minus 4x times 3x squared is minus 12x to the third. Minus 4x, I get a minus times, so that's minus 8 for those who have little difficulty with signs, x times x. Do that first, write the sign down, minus times a minus plus. Do that, then worry about 4 times 5. 4 times 5x, excuse me. So 20x, reach in here. I'm hoping I'm not making a mistake because I'm reaching. Now I'll put it in columns. 2x cubed minus 8x, well, that's over here. And 2 times negative 12, negative 24. And then you put the columns and you go, okay, that's minus 10x cubed minus 8x squared plus 12x. Oops, I forgot to write the x there. I told you I'm reaching. 2 times negative 12x and minus 24. And then I look over to the answer key, and it's what I got the last time. Doesn't mean I didn't make the same mistake, but let's move on. I got Yasser to back me up. If I make a mistake, Yasser, let me know. All right, so a lot of gaps coming in from Algebra 1. Got to close them. I think we have. Pretty sure everybody's on the right page now. So you got 3x squared, you got 2x minus 12x, so minus 10x minus 8. Confirmed over there. Equation of a line. X minus 2 minus 8 gets us started. And remember, we're trying to do m times 0 plus C, and we just did when we put a 2 in. There's your 0. Now we got to get the multiplier. From 2 to 10 is a change of 8. I seem to use the number 8 a lot in this worksheet. I don't know why. From -8 to 17 is a jump of 15. Hopefully, when you put -8 in, we can see the, I'm sorry, when you put 10 in, we can see the m times 1 plus c. So let's put 10 in so you can see it. 10 minus 2 is 8. 8 is a multiple of 8. 8 goes into 8 one time. 15 minus 8, 7. Okay, so that's a framework we're going to be using, probably half a dozen to a dozen times in this lesson set. I've asked my students to memorize root 2. You'd be surprised how long it takes a class to do that. We're using 1.41. And so if you multiply that by 3, you get 3 with a 2, carry the 1, you get 4.23. If I see something else, it's hanky-panky, keep up calculators in your pockets. All right. Confirmed over there, 4.23. So I've got a couple of functions and I'm looking for g of 3. So we're plugging 3 into x for the g function, and I can see -9. And I know I want fourths, so 7 is going to be 28. So -9 plus 28 should be 19. Yeah. So -3/4 times 3 plus 7, which is 28 over 4. Hopefully you can start doing that in your head and just writing down, what did I say, 19/4, confirming it over there. Yes, that's what I had over there. Oh, don't do that, Jim. -3/4 x, what the heck was it? Oh God, that's how bad my memory is. I don't even remember what I just saw. All right, so g of -3, not going to look for it. I didn't even need it. Got it. F of x equals 11. All right, so I almost erased that. What's another name for f of x? That's f of x, this calculation. I'm setting it to 11. I hope you can do this in your head. Add 2, 13, 4 times 13, 52 divided by 3. That's what I'm hoping you can start doing. I'm hoping you can start without writing it all. Bring the 2 to the other side, multiply by 4, divide by 3. I want to get you to train your brain in that fashion, right? Because we're going to use that construct for 90% of the equations we solve. All right, so that's gone. Let's be careful with my erasure here. Okay. 3, what do you put on top of a 3 to get 1 over 81? Well, I know my exponent has to be negative. And 3 times 3 is 9, times 3 is 27, times 3 is 81, so -4. Confirmed. All right, you do not want to have to write out a distance formula for problems like this. 6, 7, why? You want your brain to go 49, there's the right angle, 36. All right, so therefore, what does this y have to be? 13. The smaller square area is right the scarecrow. And so what is that length? That length is the square root of 13. All right, now I got a lot more space. The final frontier, 3 coordinates for this linear function. I start with the x that I see that is most important, 2. Why? Once again, we're trying to get to c, m times 0 plus c. And if I put a 2 in, I'm going to change by 5, so I'll work this column first. Then I'll work the second column. I can see that's a 7, and I'm going down 9 minus 2, and down another 9 minus 11. I'll check it on a test. I'm going to check it. I'm going to put 12 in, and I'm going to see if it comes out as minus 11. So I can get one of those, because that's where your grade's coming from. 12 minus 2, oh, 10. What a nice coincidence. I have a multiple of 5. 2 times -9, -18, plus 7, -11, move on. But try not to erase the next problem. Okay, so how do you do this one in your head? Quickly and easily. Well, we're eventually going to multiply something, right? We're going to get a certain number of x's, and in the equation, when you got a multiplier, you're solving an equation, you usually divide. So I'm looking at moving this minus 5x to the other side, which means it's 10x on the right, and I know I'm going to divide by 10. And minus 12 becomes positive 12 on the left. And I don't care if you leave it like that, because I'm looking for your thought process, but certainly minus 1/5 or minus 2/10 for me, because you're doing 70 problems in 70 minutes and you're just learning how to do that. I'll take minus 2/10. How do you do this one in your head? Well, you know, you're going to have a certain multiplier times x, and then you're going to divide. And if you're going to multiply by 15, I mean, we're going to multiply this thing by 15, then that becomes 9. That becomes minus 20. I'll move the minus 20 to the other side and put it with the 9 and divide. And I know I got a 29. Now, I got to do the multiplication here. Minus 15 is going to go to the other side with 30, and I got 45. Let's take our time with it. 45 29s. 5 goes into 15. How nice. 3 times 3x. 9x. Minus 15 equals. 3 goes into 15. Oh, how nice. Minus 20x. Plus 30. Okay, let's hope I didn't make a mistake. Bringing this way, there's your 29x. Bringing that way, there's your 45. There's our 45 29ths. All right, perpendicular. 19x plus 3y. I gotta be careful with my eraser here. So that's 19x. I always have trouble drawing a 3. Imagine that. 19x plus 3y equals 0. I want perpendicular to this through negative 3/7. Well, one of the recent videos, we said, oh, you can find the original function, just the rate of change of the original, just by changing the sign and dividing it into 19. That's the original slope. The perpendicular slope is immediately spotted. I can see it immediately. So all I have to do is, for a parallel, x plus 3 plus 7, and for a perpendicular, x plus 3 plus 7. Now let's take our time to see why this is the perpendicular. All right, so I'm going to move the 19x to the other side. Now it's negative 19x. And I'm going to divide by y. Oh, there's my minus 19 over 3 times x. That means I'm going over 3 and down 19 per 80 steep decline. Perpendicular. Perpendicular. It's not even close to the perpendicular. Okay, perpendicular. What would it look like? If that's over 3 down 19 is even steeper. Over 3 down 19 is even steeper. And I want a perpendicular that's closer to that. I hope you can see, it's hard for me to even draw. Little change in altitude, big horizontal, little horizontal, big altitude. So one is going up, this slope is coming down, this one's going up, hence the change from negative to positive, and we flip the rise over run. Okay, that's been done for the last 13 lesson sets, so hopefully you're hearing one of those conversations. Minus 3 is just checking people's ability to work with a negative number. A minus times a minus times a minus is a minus. Okay, so I get minus 27 over 4 plus 3. I hope you can start doing that in your head. 4 times 3 is 12. Take 12 away from 27, minus 27, or add it to minus 27. And I believe you get minus 15/4. But I'm talking quickly and I'm going to check that one. 13, yeah, that's correct. Double checked over there. Okay, so that's this one. I can erase this one. Yep. Okay, I think I want the inverse of this. I think I asked for the inverse. And when the inverse is based on as a function an x value as well. And these are y values, just like these are y values. And so if I'm going to get a y value out, let's say I want some number here, I'm solving an equation, putting a number in, getting the number out. This is what I get out. But I'm going to plug it into the inverse. So it's really solving an equation. So if you had a number over here, in this instant, you can subtract 1, the inverse of log base 4, I hope. we're starting to see that it's exponentiating, and subtracting 5 is adding 5. So I got an exponential function. I don't want to write the 5 there. Okay, right there. Okay, I got an exponential function. I got a log, they're inverses. How do we check to see if it's true? We plug a number in. I'm going to plug the number 9 in. I hope you can see why. 9 minus 5 is 4. What's the exponent you put on top of a 4 to get 4? 1 plus 1 is 2. I just plugged a 9 into G and I got a 2 out. So G of 9 equals 2. So therefore, G minus 1 of 2 had better get me 9. So I'll put a 2 in. 2 minus 1 is 1. 4 to the 1 is 4 plus 5, 9. I'm moving on. I wrote the correct answer over there as well. Good practice. That's 14. Being careful now. Repetition's my friend. I'm not erasing the next problem. So I want you to be able to do this in your head. I'm hoping that you can see what number's a perfect square in there and write it. You don't have one over here, so write it. Perfect square, so write it. Z to the 5th, 2 of them come out, 1 of them stays in. 2 squared is 4, and 4 times 3 is 12. So I'm hoping you can kind of just write that answer. But I could have also written it as 4 times 3 times y to the 1 squared z to the 2 squared times z. Okay, that's writing it out. Okay, so I'm basically just dividing 2 into 5 with 1 remainder, 2 into 2 once. I'll write the 1. This one you have to spot in that fashion, hopefully. Okay, see, that was 14. Did I write the right answer on the answer key? I did. As long as I didn't make the same mistake twice. So I'm careful with my erasing now. Yes, completing the square. So x squared minus 10x plus 15. It's okay on your test to write the following. That shows me you know the process. That's what I'm interested in finding out. We talked about this enough in previous lesson sets. I'm at that stage now. Okay, it's your job. It's your job to see 15x to the 6 minus 5 over 10x cubed. You need to figure out why I'm saying 3 halves x cubed minus 1/2 x cubed. Yeah, you got it. If you're not getting right answers, you got to stop for a minute and look at it and say, what are the rules? All right, factoring. 49x squared, which is a square, minus 4y squared, which is another square. And we're going to work with the square roots. And I see a square root over on this side. I see one on that side. And the subtraction of two numbers can always be written as the sum of their square roots. The sum of their square roots times the difference of their square roots. Let's prove that with 25 minus 9, which is 16. Could have been written as 5 plus 3 times 5 minus 2. This allows me to do division and cancellation. So it's good to write sums and differences as products, especially if you're working with division, which is one of the future problems on this lesson set, I hope. So that's 18, 19. Let's come down this way a little bit. All right, I'm hoping that folks don't have to write out 5x minus 2 times 5x minus 2. But if you are, just look at your answer. 25x squared, square the first. Oh, that's minus 10x. In your answer, you got minus 20x. I wonder how I can make minus 10 into minus 20. Squaring the 2, 4. I'm hoping that you're not having to do that anymore at this stage of the term. If you are, look at the answer. Could you have gotten it from the original without having to do that? And the answer to that is yes, you can save yourself a lot of work and time by putting a little effort into seeing how that was done so you don't have to keep working with more effort. Same thing here. Do they have a common factor? The biggest one, the greatest common factor? Yeah, I'm hoping you're seeing 8. Right? If this has a square root of 8 and that has a square root of 8, the square root of 8 times the square root of 8 is 8. And there's a 2 in here and a 3 there, which is a root 6. That's how you can do it in your head. Now, what did I do? I actually wrote it out this way. Square root of 8 times the square root of 2, square root of 8 times the square root of 3. Multiplication, you can rearrange. So square root of 8, square root of 8, square root of 2, square root of 3. And I hope you can see 8 root 6. I see 49 times 10. 49, the square root of 49 is 7. Root 10. That's what I'm seeing. Quadratic. Again, try to keep your eyes open for what in this test? M to the 0 plus c and m to the 1 plus c. That's what we're doing each and every time for most of the functions that we're going to do on this test. Follow this rule. So how do I get a 0 out of a 4? X minus 4. And how do I make it a quadratic? Squared. Doesn't matter if it's squared. 4 minus 4 is 0. I don't care what exponent you put it to. You're going to get a 0. If you want a 7, you get to write 7. Now, what was the multiplier? Well, from 7 to 9, I jump by 2. And if I put 10 in, I get 36. And 36, when I put a 10 in, makes the number 1. 6 squared is 36. Oh, how nice. Oh, what a coincidence. And I get 2 times 1 plus 7, which is 9. All right, can you do this one in your head? Can you subtract 25 from 30 and get 5? Can you divide by 3? Can you take plus minus square root? Can you envision this? If you can, it's a 10-second problem. Just the amount of time to write it down on a piece of paper. Imagine that, if they were all 10-second problems. 43 times 10. 430 seconds. 7 minutes, roughly. To do the first 43 problems. Okay, can you conceptualize that now? And we'll do it out mechanically, but can you see you need a square root and a cube? There's the cube, there's the square root. Okay, what did I do? I'm trying to find the exponent on top of 25. That gets me 125. I know 25 is 5 to the 2x, and 125 is 5 to the 3. So therefore, 2x has to equal 3. Bingo, 3 halves. All right, just some algebra 1 factoring here. What two numbers multiply? You can do this when the coefficient is 1. I think we're looking at a 2 and a 9. Okay, so get the x, get the 9, get the x, get the 2, and worry about the signs later. Bigger product. Middle terms interact. One's got to be positive, one's got to be negative. Who's going to win the battle in the ring? The positive gets the plus. Negative. All right, got a lot of sign errors still. Too many. Check your work. What's another way to check your work? Put a 1 in. 1 plus 7, 8 minus 18, negative 10. Put a 1 in. 10 times negative 1, negative 10. Move on. Graphing form, finding the roots. Well, no sense putting it in graphing form if we have to find the roots. We might as well just sketch it. Cup shape up. Minus b, minus 12 divided by 4, negative 3. What goes with a negative 3? Negative 36 cut in half, negative 18, negative 18 plus 5, negative 13. So what are the roots? I got an a value of 2. All right, so therefore I'm measuring my x's from negative 3 plus minus. I can definitely see that y equals 0 exists, so no imaginary roots. So 13 divided by 2. How do I know that? I took enough time to see the graphing form, which is 2 times x plus 3. There's our 0 again, making a 0. minus 13, setting it to 0. Well, what are you doing? You've got 13 on this side. Okay, well, there it is. You divide by 2. 13 divided by 2. Okay, that takes care of that. We got a plus minus square root, and we're measuring from positive 3 comes to the other side and becomes negative 3. Okay, takes care of that. 5x plus 2y equals 40. 5x is a term. It's also a product. All right, 5 times x. And what's the easiest number to multiply by? 53 times 97. That's what I would multiply 53 by. I'd pick 97. It's the easiest. Oh, no, it's not. Oh, well, what's the easiest? 53 times 0. What's the next easiest? 53 times 1. We're creating that throughout the entire test. So make this 0, and y is 20. If x is 0, y is 20. Anytime you make x 0, you're looking at a y-intercept on a graph. Let the y be 0. X is 8. I don't know why I like the number 8 on this worksheet. You got the line. That's standard form, and that's how you work with it. And I'm running out of ink, so I got to find another marker. So just give me a second here. And I hope that they're in this box. Now I've got 2. One of them ought to work. 2a squared minus a minus 15. On the last test, I gave you 2a squared plus a minus 15. All right, so make that a minus this time. 2a and a. I'm looking here because whatever number I put here, it's going to double. I'm going to throw that 3 because that gets me 6. 6 and 5 are 1 apart. Who wins? The bigger product. Well, the bigger product is this one. Not looking over there anymore. I'm just assuming those are right. Okay, 30. No work necessary. Come on, Rennie, let's go down a little bit. Center this. There's no work necessary here. These are products. If we have a product, what makes zeros? What makes a 0 here is 0. What makes a 0 here? 10 over 3. What makes a 0 here? Minus 11 over 204. Those are the real answers, no complex answers. Those are the x values that give me this product being 0. All right? Minimum. Okay, minimum. I'm going to make that 6 divided by 6 is 1. 1 is going to get me my minimum. That's your answer, the y value. So we put a 1 in, minus 3 plus 11, 8. I don't know what it is about the number 8, but that's your minimum. Check that real quick. I'm getting towards the end of the video. This is when I start to get a little brain fatigue. Maybe I should take a stool, like, in the ring, take the 30 seconds, get a little help, get psyched up a little bit for the second round. Okay, we're good. So what am I looking for? Y-intercept. I just want your brain to say y-intercept, let x equal 0. And then use your x. Minus 8 times 5 minus 40. 0 gets me minus 40. That's your y-intercept. All right, coming fresh off the stool, 32. Yeah, that's what I got there as well. All right, so we got 2 functions. Almost got back to erasing that. G of f of negative 3 on an SAT. For those of you who have to take those, it would have written this way. G of f of negative 3. So we put negative 3 in here. And we get negative 3 plus 6 is the square root of 3 plus 5. Yeah, that's what we get. And then we're going to double that and subtract 15. We're going to double it and subtract 15. I do not remember doing this problem. Why don't I remember doing this problem? Because I didn't do it over there. 33. I see a 1 over there. Why do I see a 1? Oh, I bet maybe I copied it wrong. Maybe it's positive 3. Right? If it was positive 3, that would have been 3, 8, 16. Okay. But I have negative 3 written here. So, yeah, if you got a 1, you're probably checking right now. what I'm doing. So I hope I explained it. So let's go with what's written here. That's 2 root 3, 10 minus 15 minus 5. And I'm hoping people know what the root 3 is. I've asked people to memorize root 3 as well for our class. We're using 1.73 as an approximation for root 3. We're starting some serious trig on Wednesday. And so if we're starting the trig, you're going to need to know those values. Otherwise, you will not have a feeling for the size of the functions you're working with. The inverse of g, so I'm going to erase this now, erase that, and I'm doing the inverse of this. Again, if you were solving an equation for some number, what steps would you take? I hope you would add 15 and divide by 2. This does not always work for every inverse function. For the vast majority, it does. How do we check? Let's put a 10 in. A 10 gets me 5 in the g function. A 5 gets me 10 in the inverse function. Move on. All right, mental math this. You know you're going to square x. You know you're going to multiply it by -5. So write minus 5x squared. You know you're going to double that product. So 2 times x doubled is 4x times minus 5 minus 20x. You're going to square the 2. 4 times -5, -20, plus 7, -13. And that was 35 minus 5x squared minus 20x minus 13. We're good. Just to double check. I don't want Yasser having to write too much. Mental math this. What's common to 18 and 12? 6. So we immediately write 3 and a 2. What is common between a to the 7th and a to the 6th? A to the 6th. That means I need one more there to get a to the 7th. I already have a to the 6th when I multiply that times 2. 29 and 27, I'm seeing 27. Need a little more space, x to the 27, which is contained in the second one, so I don't need to write it there, but I do need another 2 to get the correct number of factors. And you can just write that on your answer key. You don't have to copy it down. You don't have to, whatever. All right, can you conceptualize what you have to do to an 8 to turn it into a 2? I hope you say I got to take a cube root. This is 8 over 1. How do I make it flip? Minus 1/3. So 8 is 2 to the 3. I'm looking for the exponent. That gives me 2 to the -1. I hope you can see 3x equals -1. And you can see where that answer materializes. All right, so let's do that here. Mental math. Flip it, you get a 9. Take a square root, you get a 3. You cube it, you get 27. So what did I do? Did 1/9 to the -3/2. I employed this character and I brought him to work. And that becomes 9 over 1 to the 3/2. And I've used that operation. I'm going to use this operation, which is that. And the last thing I do is cube 3. There's my 27. Okay, here's another example of. We want m times 0 plus c, and we want m times 1 plus c. Can you see it happen? When I write the square root of x minus 8. This is a square root function. I think I made that. I think I'm going to get c, 19. I multiply here. I know I've got to go from 19 to 2, so I need that, which means I got to get a cancellation here when I use the number 15. And when I put the number 15 in here, I get the square root of 7. Now you take a moment, and if you figure out how to do that, you understand it, then you should be able to effortlessly write those equations each and every time. All right. 0, 11 to 5, 8. We want the distance from 0, 11 to 5, 8. I'll write it in a table. 0, 11 to 5, 8. Well, this is what I'm seeing. I'm seeing a horizontal of 5 and a vertical of -3. I'm seeing 25 and 9. I'm seeing the square root of 34. Hypotenuse will always be positive because you're adding up square areas, right? Square areas are always positive. 25, take away 10 plus 9. Hopefully you see that. We're at 34. All right, so here's one of those where we hopefully can do this in our head. We'll do it together, but if you can do this in your head, wonderful. Okay, add 6. 1/2 to the 4. 1/16. X over 2 equals 1/16. So X equals 1/8. I hope we can see that 1/8 divided by 2 is 1/16. So if I put a 1/16 in here, what do I have to do to 1/2 to make it 1/16? I've got to 4th power it, and 4 minus 6 is -2. All right, so x squared plus y squared equals 25. What is this similar to? It's similar to the problem we did before. I forget exactly what it was, but we had something like 24, something like that. It's like a standard form. What do? You plug 0 in. And if you plug 0 in, you can see answers. So what do you do here? You plug a 0 in. I hope you can see answers. And also you could plug a 0 in for y. And what happens if you plug a 0 in for y? You see answers. Well, you can plug a 0 in for y and hope you can see answers. And I hope you start in a spot. Boom, 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 boom. We got ourselves a circle with another coordinate here like 3, 4. 3, 4. It's also on there. So is 3, -4. So is 4, -3, so on and so forth. Okay, so we're building ourselves towards how do we write the equations of circles? In fact, that's on the test. And we use completing the square. Well, what were you working with? You were working with squares. All right, last problem. Wow. All right, got this done. Actually have breakfast, come back, and then do the second half of the test. All right, so it's a word problem, and people don't have the entire thing written out, but it was basically you start with $50, you put it in a savings account, and you triple your money every 27 years, and we did this last year, 2024. All right, so we start with $50, so amount as a function of time is we start with $50. We triple it every 27 years, starting in 2024. Okay, just a little context to an exponential function whose asymptote was 0, right? Constant 0. And so somebody starts with 50. It triples. Triples again, 450. There's your exponential function. Started with 50 and it's tripling. Every what? 27 years. And hopefully as we keep having these brief conversations, makes more sense. All right, so that's that. I don't know, maybe some feedback. Did it help by putting an answer key up? Did it help by having I don't know, is a screenshot appropriate? Not sure how to communicate, but the future lesson sets just keep building off of these topics where the next circle is a little more difficult. I think it's coming up in the next 25 problems or so. The graphs get a little more challenging. We start speed graphing e to the x. We start speed graphing ln of x so that they're just can be done like that. That's what we're trying to do with the repetition. It's like getting a touch on a soccer ball. Got to get out there and knock it on a wall. All right. Put a piece of tape so you're trying to hit something. All right. Good enough. And hopefully this is working for some folks. All right. Toodaloo.